Algebra 2, Monday, March 23rd, 2020. Hope you guys had a good weekend. Hopefully you guys are still healthy, and hope we can get through this. I just wanted to give you guys the first 14 to be a warm-up problem, to be a warm-up set. So pause the video for the first 8. If you want more. There's the last 6. Okay. So pause the video if you need more time at any point. So let's take a look at the square root of 256. Just to give you a softball kind of problem. So I don't want to take away from the fact that you could use the square root button. By any means, please use the square root button. So if I plug in the square root of 256, I'm going to get 16. I just wanted to see if you guys are flexible enough to know how can I convert this as an exponent. So if I take 256 and I take that to the 1/2 power, I would also get 16. So the square root of 256 is in fact 16. Okay, moving on to problem number 2. The cube root of 1,000. What number times itself 3 times? So blank times blank times blank is 1,000. So I would use the calculator and go 1,000, oops, not decimals, 1,000 caret, and I want to do the cube root, so what power do I need to take it to? I'm going to take that to the 1/3 power, and that would get me 10. Why? Because 10 times 10 times 10 is in fact 1,000. So the cube root of 1,000 is 10. Hey, 9 to the 1/2 power. The 1/2 power is exactly the same as the square root. So let's just think about this. The square root of 9 is in fact 3. And looking at number 4, 64 to the 1/3 power is the same thing as taking the cube root. So if I take 64 to the 1/3 power, I think it's 4, and it is. 4 times 4 times 4 is in fact Nintendo 64. All right, moving on to problem number 5. Sorry if I do that a little bit bigger than normal. I scribbled and I just wanted to save some space. But that is the 5th root of 32. How do I calculate the 5th root of 32? So I get 32. I take it to the 1/5 power. Oops, not 159. The 1/5 power is in fact 2. Now we're in tricky territory. 343 to the 2/3 power. Remember that when we look at a rational exponent, we have a top, we have a bottom, a numerator and a denominator. The numerator is the power, the denominator is the root. And you guys remember my tormented lecture where I said, I prefer to take the root first before I take the power. So I could do this in 2 steps, or I can do this in the calculator. So I'm going to put this in the calculator and know that in my head, I'm going to take, looking at this, I'm going to take the 3rd root, the cube root, and then I'm going to square it. So if I take 343 caret, 343 caret 2/3 power, it's going to get me 49. And the reason why is, if you get enough practice with this, the cube root of 343 is 7. And then 7 squared is 49. So 343 to the 2/3 power is going to be 49. We left off on Friday exploring 3 new rules. What happens if I take a number to the 1st power? Nothing exciting, it's just itself. So 18 to the 1st power is merely 18. What happens if I take a number to a 0 power? So let's say I take a big number. Let's just go with 45. 45 to the 0 power. Well, anything to the 0 power, except for a 0 base, so 0 to the 0 power, everything to the 0 power is going to be 1. Now, what happens if I take a negative exponent? 8 to the negative first power. Well, a negative exponent becomes a positive exponent in the other spot of the fraction. So remember that this is 8 to the negative first power, and I could make that over 1. So if I had a fraction, 8 to the negative first power, I would flip that base 8 to the bottom, make that a positive first power right there, right? So it would be a fraction 1 over 8 to the first, or the very, very exciting 1/8. Because 8 to the first power is just 8. Number 10. 3 to the negative fourth power. Okay, once again, I'm going to rewrite 3 to the negative fourth power. A negative exponent becomes a positive exponent in the other spot of the fraction. So I have 1 over 3 to the fourth power. And if I calculate 3 to the fourth power, I'm going to get 81. So 3 to the negative fourth power is just 1 over 81. Okay. 7 to the negative second power. A negative exponent becomes a positive exponent in the other spot. So that becomes 1 over 7 squared. And 1 over 7 squared becomes 1 over 49. Okay. Number 12, 6 to the negative third power. Well, a negative exponent becomes a positive exponent in the other spot. So that becomes 1 over 6 to the positive third power. You get enough practice with this? 6 to the third power is 216. So that's 1 over 216. Okay? So you could plug this into the calculator, no problem. 4 to the 5/2 power. Remember, the top is the power, the bottom is the root. The numerator is the power, the denominator is the root. So what does it mean if the denominator is 2? That means it's looking for the square root of 4. So I'm going to try to do this without a calculator, and then I'm going to plug it in and see if I'm right. So I'm going to do the square root of 4. And then I'm going to take it to the 5th power. So the square root of 4 is going to be 2. And then I'm going to take 2 to the 5th power, which is going to be 32. I'm just going to check my work really quick. Clear, 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 clear. 4 caret 5/2 is just 2.5. So if I take 4 to the 2.5 power, that would also be 32. Okay. 14. Last warm-up problem, and then we'll get to the we'll build upon what we just previously learned. So 81 to the 3/4 power. Once again, I'm going to take the 4th root of 81 and then cube it. Again, you could. I don't want you guys to feel like you have to do this every single time. You can plug it in the calculator. I'm just challenging myself at this point. The 4th root of 81 is 3. 3 times 3, 3 times 3 times 3 times 3, 3, 9, 27, 81. So that'd be the 4th root of 81 is 3. And then I'm going to take that to the 3rd power. 3 to the 3rd power is 27. And if I take 81 to the 3/4 power, or 0.75, you would get 27 as well. Okay? Turn the page. All right, here we go. So now I'm going to give you guys a couple hints because this got me through pre-calc actually. So when you're taking the root or an exponent, pay attention to whether your root is even or odd. Also, pay attention to whether the base is positive or negative. So is the root even or odd, or is the base, and is the base positive or negative? So what do I mean by that? Well, let's just go back to an easy problem. The square root of 36. The square root of 36 is 6 because 6 squared is 36. Now, if I go in the calculator, go back to the test that we had before we had to leave class for the coronavirus. If I took the square root of negative 36, my calculator responds by saying, that's not a real number. We had to expand this world and create the imaginary number system that our calculator doesn't understand. So, if I were to take the square root of negative 36, it would be 6i, but let's go back to reality. Oh, there goes gravity. We've got the square root of negative 36. We've got, for now, let's call it undefined, or not, I should say not real. Even though you and I both know that it is 6i. Okay? Now, if I take the cube root of 125, that would be 5, and the reason why is because 5 to the third power is 125. No issue there. But then, if I take the cube root of negative 125, right? So let's say I take, parentheses are your best friend, by the way, negative 125, oops, can't hold the iPad and type at the same time, 125, close the parentheses, and I take that to the 1/3 power, it's going to get me a real number, negative 5. So the difference between a square root and a cube root, I get an answer. Okay, we'll figure that out later. But in this case, the cube root of negative 125 is negative 5. Oh, I see. Because if I took negative 5 and cubed it, right? I'm just going to expand it out really quick. That's negative 5 times negative 5 times negative 5. A pair of negatives would form a positive, but then that positive would multiply another negative, and that would get me a negative. 5 times 5 times 5 is 125. So that makes sense. Okay. So then we take a look at this, and I wish I knew how to count. That'd be problem number 5, not problem number 4. So I'm going to put a 5 here and a 6 here. I apologize, folks. The fourth root of 81. Well, the problem's still going to be the same. How do I take the fourth root of 81 again? I take 81 and I take that to the 1 divided by 4 power in parentheses, and that's going to get me 3. Okay, no worries, because that makes sense. 3 to the 4th power is 81. But let's take a look at this. I'm looking for the 4th root of negative 81. So let's say I put negative 81 in the parentheses, and I'm going to take that, the 4th root, as in the 1/4 power, and let's see what I get. I get, hey, that's not a real answer. So the same thing happened in problem number 2 as it's happening in problem number 6. This is not real or undefined. So can any of you guys make the connection between problem number 2, problem number 4, and problem number 6? What's wrong with taking the square root of a negative number? What's wrong with taking the cube root of a negative number? And what's wrong with taking the, what's okay about taking the cube root of a negative number, but what's not okay about taking the 4th root of a negative number? So, the main idea is a negative base usually causes trouble. A negative base can only take odd roots in the real number system. Okay? A negative base can only take odd roots in the real number system, because that's the foundation of how we've come up with imaginary numbers. I'll just give you a free pass. If we have the square root of a negative number, the fourth root of a negative number, the sixth root of a negative number, and so on and so forth. So if the base is negative, pay attention to whether if the base is negative, pay attention to whether the root is odd or even. Because if it's negative and we have an odd root, totally cool. If we have a negative base and an even root, that's impossible in the real number system. Okay. So then, last page. So the last 8 problems of the day. See if you guys, I'll put these in 4s. See if you guys can do these problems. Oh, wait, we haven't done these 4 yet. But then, when you're done with that, take a look at these. Okay, so let's check this out. 9 to the negative 1/2 power. Okay, is the base positive or negative? It's positive, but what's the exponent? Okay, it's a fraction of the exponent, but it's also a negative as well. So I'm going to do this in 2 steps. So remember, a negative exponent becomes a positive exponent in the other spot of the fraction. So I'm going to leave this as 1 over 9 to the positive 1/2 power. Okay, now I can deal with this 2-step process because the 1/2 power is the same thing as the square root. So 1 over 9 to the 1/2 power would be 1/3 because the square root of 9 is 3. Okay. How about this? Ah, man, so I've got a positive base, a negative exponent, and it's also a fraction. That really annoys me. So let's take this in 2 steps. It might even be 3 steps, actually. But the base is positive, and we've got a negative exponent. That becomes 1 over 32 to the positive 3/5 power. So then I'm going to take the 5th root of 32, 2, and then I'm going to cube it and form 8. You can check your work with the calculator. So that'd be 1 over 32 to the 3/5 power, which forms 8, 1/8. Okay. 64 to the negative 4/3 power. See if you can do this problem independently. Okay. So once again, I've got a positive base, but a negative exponent, so I'm going to make this 1 over 64 to the positive 4/3 power. Then I'm going to take the cube root of 64, 4, and then I'm going to take 4 to the 4th power, or I could just plug it into the calculator and get 256. So 64 to the negative 4/3 power, let me just plug that in. Let me just plug that part into the calculator. 64 caret 4/3. I just wanted to double check my work. I have a bachelor's degree, but that doesn't mean I don't make mistakes. I make plenty of mistakes. Yep, 64 to the 4/3 power is in fact 256. Doesn't hurt my ego to check my work. So then if I do problem number 4, which is 81 to the negative 5/4 power. Well, that becomes 1 over 81 to the 5/4 power. So then, let me make that 5 a little bit neater. There we go. The 4th root of 81 we revealed was 3. And then I'm going to take 3 to the 5th power. Even I don't know that in the count. Actually, I think I do. I just want to double check. Is it 343? So then if I take 3 to the 5th power, 240. See, even I, even I am wrong every once in a while. 243. But let me just double check once again with the big fraction. 81 to the 5/4 power. That should also be 243. Check your work in a variety of ways. That's my best advice as you get higher and higher in high school. High school math, I should say. So that's 1 over 243. Okay. This is where we run into trouble. Once again, the base is negative. What is the 1/3 power? The cube root. Is this problem possible? Yes. So a negative base with an odd root is legal. So if I check my work, I've got negative 64. Sorry, I'm going to put that in parentheses so I don't mess up. Negative 64 to the 1/3 power is going to be negative 4. Because negative 4 times negative 4 times negative 4 is negative Nintendo 64. So that checks out. Moving on to problem number 6. Negative base to the 1/4 power. Is this problem solvable? So this is not real. Or if you want to put undefined, you can. But I like not real because when you actually go into college, I actually took a class in college called abstract algebra, where there's a whole world of math along with the square root of a negative number, the fourth root of a negative number. It was really, really hard, actually. But it was one of the most rewarding classes I ever took. Was called abstract algebra. It'll make your head spin. So let's take a look at negative 32 quantity to the 3/5 power. Negative base. What's the root? The 5th root. So is this problem solvable? Yes. So I'm going to do this problem in 2 steps because I want to challenge myself. So if I take the 5th root of negative 32, again, plug it in the calculator if you want to get an answer. I'm just showing you how it works. I'm showing you why it works, rather. So the 5th root of negative 32, so if the 5th root of 32 is 2, then the 5th root of negative 32 has to be negative 2. And then I'm going to cube it, and that should get me negative 8. Okay. Last problem of the day. What's the difference between problem number 7 and problem number 8? Oh, the bases are both negative, but the power is also negative and a fraction in problem number 8. Way to challenge yourself. So I'm going to do this like so. I'm going to keep the negative in parentheses. So this is going to be 1 over negative 32 to the positive 3/5. So then, once I saw that earlier, negative 32 to the 3/5 power is negative 8. So this whole thing is negative 1/8. Hope you guys enjoyed this. I will see you again tomorrow.